Somewhere on this planet, something is breathing that was alive before the pyramids were built, before Rome rose and fell, before the first word was ever written. It is not a fossil, not a trace of something that once existed. It is alive, right now, still growing. We often think of life as fragile, temporary, a brief flicker between birth and death. But there are organisms on Earth that have defied this rhythm. Creatures and plants that have witnessed millennia pass. Ice ages, mass extinctions, the rise and collapse of entire civilizations. And they have simply continued. This is not myth. This is biology. Scattered across the planet, in forests and ocean floors, in frozen soil and ancient seabeds, there exist living things so old that their age challenges our understanding of what life even means. Some are trees, twisted and weathered, clinging to mountainsides where nothing else survives. Some are colonies, vast networks of roots and cells that share one genetic identity across thousands of years. And some are smaller, microscopic, trapped in salt crystals or buried miles beneath the earth, waiting. The question is not simply how old they are. The question is why they are still alive. What makes one organism perish in decades while another endures for 10,000 years? What separates the mortal from the nearly eternal? Science has spent centuries trying to understand death, but perhaps the deeper mystery lies in understanding survival. These ancient organisms hold answers, locked in their DNA, written in their slow, patient biology. They have solved problems we are only beginning to ask. To find them, we must travel to the harshest places on Earth. Places where time moves differently, where the rules of life bend and stretch into something unfamiliar. We will walk among trees that sprouted when woolly mammoths still roamed. We will trace the roots of a single organism that spans over 100 acres of forest floor. We will descend into the deep earth, where bacteria have survived in isolation for millions of years, feeding on nothing but rock and radiation. And we will ask the question that haunts every biologist who has stood before them. Why do they live when everything else has died? There is no single answer, no simple trick of genetics or environment. The oldest organisms on Earth are not survivors by accident. They are masterpieces of adaptation, of patience, of a kind of biological stubbornness that borders on the impossible. And their existence raises uncomfortable questions about our own. If life can persist for millennia, why doesn't it? Why is death the rule and not the exception? To understand, we must begin where the air is thin and the soil is ancient. We must climb. High in the White Mountains of California, where the air thins and temperatures swing from freezing to scorching within hours, something impossible stands against the sky. A tree, twisted, gnarled, barely alive by any visual standard. Its bark is stripped. Its branches are mostly bare. It looks like it died centuries ago, but it hasn't. This is a Great Basin bristlecone pine, and some of them have been alive for over 5,000 years. 5,000 years. When these trees were seedlings, humans had just begun to invent writing. Copper was the height of technology. The concept of a wheel was revolutionary, and these trees were already growing. Bristlecone pines are not tall, not grand in the way we expect ancient things to be. They do not tower over the landscape like redwoods. They do not spread wide like oaks. They are small, crooked, battered by wind and ice. And yet, that is precisely why they survive. Their wood is incredibly dense, saturated with resin that resists rot, fungi, and insects. Even when most of the tree has died, a thin ribbon of living bark can continue to transport nutrients. A single strip of life sustaining the whole organism for centuries more. They grow slowly, sometimes adding less than an inch of width per century. In a world that rewards speed and size, the bristlecone pine has chosen the opposite path. Patience. The oldest known living bristlecone is named Methuselah. It germinates around 2833 BCE. Its exact location is kept secret to protect it from vandalism. There is another, discovered in 2012, that may be even older. Scientists have not named it, have not revealed where it stands. It simply exists, quietly, a living monument to endurance. But trees like Methuselah raise a difficult question for biologists. Why don't they die of old age? Most organisms accumulate damage over time. Cells divide, errors appear, systems break down. This is aging, and eventually, it kills. But bristlecone pines show remarkably low rates of cellular aging. Their oldest tissues function almost as well as their youngest. Their genetic machinery does not seem to degrade in the way ours does. It is as though they opted out of the biological contract that governs the rest of life. Scientists believe the extreme conditions help. The cold, the dry air, the poor soil. These trees grow so slowly that damage accumulates at a glacial pace. Their metabolism is a crawl, and in that slowness, they find time. But this is only a partial answer, because something in their biology allows this slowness. Something in their DNA has unlocked a door that most organisms never find. The bristlecone pines are the oldest individual trees, but they are not the oldest living organisms. That title belongs to something far stranger, far larger, and it lives beneath the forest floor. In the Fish Lake National Forest of Utah, there is a forest of quaking aspens that stretches across 106 acres, 47,000 trees, golden leaves shimmering in the autumn wind. It looks like a forest, but it is not. It is one organism. Every single tree in this grove shares identical DNA. They are not neighbors. They are not siblings. They are the same being, connected beneath the soil by a single, massive root system. This organism is called Pando, Latin for I spread, and spread it has, for an estimated 80,000 years. Pando is not a tree. It is a clonal colony. The trunks we see above ground are like the fingers of a hand. They emerge, grow, die, and are replaced. But the organism itself, the genetic entity that we call Pando, has never died. It has simply continued, regenerating, expanding, surviving fire, drought, and ice ages. When the glaciers retreated from North America, Pando was already ancient. This forces us to reconsider what we mean by life. Is Pando truly alive in the way we understand it? Is it one organism or many? When does a connected system stop being an individual? Biologists argue about this. The definitions blur. But genetically, Pando is singular. One identity. One unbroken line of existence stretching back before recorded history. And it weighs an estimated 13 million pounds, the heaviest known organism on Earth. Clonal colonies challenge our ideas of mortality. Because the individual trunks do die, they age, they fall, but the root system persists. It is as though death only affects the visible portion of life, the part we can see and measure. Beneath the surface, something continues. Pando is not alone. Across the world, other clonal organisms have achieved similar timescales. In the Mediterranean, there is a seagrass meadow called Posidonia oceanica that has been dated to over 100,000 years old. A single genetic organism, stretching across miles of seafloor. In Tasmania, a King's Lomatia shrub reproduces only by cloning itself. The individual plants live around 300 years, but the clone has been genetically identical for over 43,000 years. And in Oregon, a honey fungus spans nearly 10 square kilometers. Its age is debated, but estimates range from 2,000 to 8,000 years. These organisms survive because they have decentralized life itself. No single trunk, no single stem, no single point of failure. If one part dies, another grows. The network persists. It is a strategy that seems almost designed to outlast time. But there are other strategies, older ones, strategies that require no roots, no leaves, no sunlight, strategies employed by organisms so small we cannot see them, so ancient they remember a world before trees existed. We must now go deeper, beneath the surface, into the dark, 2 miles beneath the surface of South Africa, in a gold mine where temperatures reach 140 degrees Fahrenheit. Scientists discovered something that should not exist. Life. Not fossils. Not residue. Living bacteria. Thriving in conditions that would kill almost anything else. They are called Candidatus desulfurutis audaxviator, a name nearly as strange as their existence. These microbes live in total darkness. They have never seen the sun. They survive on energy from radioactive decay in the surrounding rock. They are completely independent of the surface world, and some of them may have been down there for millions of years. This discovery shattered assumptions about the limits of life. Biologists had long believed that all life depended, ultimately, on sunlight. Photosynthesis at the bottom of the food chain. Energy from our star. But these bacteria proved otherwise. Life, it turns out, can exist on almost nothing. It can feed on rock, on radiation, on chemical reactions so faint they barely register. And in such minimal states, life can endure for timescales we can barely comprehend. In Siberia, scientists have revived bacteria from permafrost samples over 500,000 years old. In New Mexico, microbes were recovered from salt crystals dated to 250 million years ago. They were dormant, suspended, but when placed in nutrient solutions, some of them woke up. 250 million years of sleep. Then life. How is this possible? The answer lies in a state called cryptobiosis, a kind of suspended animation where metabolism slows to nearly zero. The organism does not eat, does not reproduce, does not respond, but it is not dead. It waits. Certain organisms have perfected this waiting. Bacterial spores can resist heat, radiation, desiccation, and vacuum. They form shells around themselves and shut down all activity. In this state, time loses meaning. 1,000 years passes like a moment. 1,000,000 years is survivable. It is not living in the way we understand it. But it is not death either. It is something in between. These discoveries force a question that extends beyond Earth. If life can survive in radioactive rock and ancient salt crystals, where else might it be waiting? Mars once had water. Europa has a subsurface ocean. Enceladus vents organic molecules into space. The organisms beneath our feet suggest that life may not need much to persist. A crack in the rock, a drop of moisture, time. And if life can wait for 250 million years, what might be waiting beneath the ice of distant moons? But survival is not just about endurance. It is about design. In our final step, we must ask the deeper question. Why have these organisms solved what we cannot? There is a pattern in the oldest living things. They do not rush. The bristlecone pines grow slowly. Pando spreads gradually. The deep earth bacteria barely metabolize. They have abandoned speed. They have rejected urgency. And in doing so, they have found time. Modern biology tells us that aging is damage. Mutations accumulating in DNA. Proteins folding incorrectly. Cells dividing until they can divide no more. For most organisms, this damage is inevitable. Programmed, even. Death clears the way for the next generation. Evolution favors reproduction over longevity. But the oldest organisms seem to have sidestepped this bargain. They accumulate damage more slowly. They repair what breaks. They decentralize their existence so no single failure is fatal. They are not immortal, but they have learned to delay the inevitable. Scientists now study these organisms for clues. The genetics of bristlecone pines, the cellular behavior of ancient bacteria, the regeneration of clonal colonies. Somewhere in their biology are instructions we have not yet decoded. How to slow time, how to repair endlessly, how to persist. But there is a philosophical dimension here too. These organisms are alive, but they do not experience time as we do. The bristlecone pine does not know it is 5,000 years old. Pando does not celebrate its birthdays. The deep earth bacteria have no awareness of the epochs they have witnessed. They simply exist, without memory, without anticipation. Is that life? Or is it something else? We seek longevity because we fear death. We want more time to experience, to love, to understand. But the oldest organisms on Earth do not experience anything. Their survival is passive, unconscious, a kind of biological inertia that mimics eternity. Perhaps that is the cost of living forever. And yet, we cannot look at them without awe. A tree that sprouted before the alphabet existed. A fungal network older than civilization. Bacteria that outlasted the dinosaurs. They carry within them a record of Earth's history. Their DNA has been shaped by climates, catastrophes, and eras we will never see. They are witnesses, silent and enduring. So why are the oldest organisms on Earth still alive? Because they found ways to cheat the clock, to grow slowly, to spread widely, to sleep through catastrophe. They traded experience for persistence, complexity for stability, individuality for continuity. And in doing so, they became something close to permanent. Whether we can learn from them remains an open question. Our biology is different. Our cells are programmed differently. We are not built to wait. But their existence proves that life is more flexible than we assumed, more patient, more stubborn, and somewhere in their ancient cells, there may be secrets we are only beginning to understand. For now, they remain, quiet, unnoticed, growing in the high mountains, spreading beneath the forest floor, sleeping in the deep rock, the oldest living things on Earth, still breathing, still waiting.